Everybody should start off. We're on page 200 even. I actually want to start at the bottom of the page for this one because we're going to do our definition first. So everybody should have your vocabulary sheets out. Today we're going to do, and this is our big focus today, is going to be on rates. So a rate is a ratio that compares two quantities measured in different units. The rate for each student in this situation is the number of laps per amount of time. So our big difference, we've been talking ratios. Ratio is a comparison of two numbers by division. A ratio is a comparison of two units by division. So the big piece here, we're adding that units piece. It is really critical for today's lesson that you guys not be lazy, that you write out the units for each section in the rates. We have to have the units included. So we're going to start with an example in a swim team. So Coach Roberts wants to encourage her swim team to increase their speed. She'll give an award to the member of the swim team who can swim the most laps in 20 minutes after practice this week. The table records the results from this week's practice. So we have two people, Tia and Lisa, are looking at this data, and they're making different conjectures about who is going to win the award. I want you guys to go ahead and take a look at their reasoning. See if you can find the flaw in their reasoning. We gave you a hint that they are both wrong. So your job, is, along with those at your table, is to figure out why they are wrong. So we'll give you guys about 3 minutes to do this. Good. Okay, what do you guys think is wrong with Tia's reasoning? She says Susan will definitely win the award because she swam the most laps. What do you think?
She didn't do any math. She didn't think about it, honestly.
So what did she look at?
She probably looked at, she didn't look at how much time it took to add it together. She didn't look at the other.
She only looked at the first number, right? So Tia's problem is she only looked at the first number. Okay, so she only looked at the first one. What do you guys think Lisa's problem was, Sawyer? Hers is the opposite. She only looked at the second number. So what we're seeing here is the importance of rates. In rates, I need to look at both numbers in comparison to each other. And so this is where the basis for today's lesson is that understanding of, in order to really compare different sets of numbers, I need to be looking at both numbers. And I need to get them to something that is the same so that I can make a comparison. Okay? So that is what rates is about. It's about writing out all the information so that we know what it is we're comparing, number one. And number two, to get to a point where we have a common comparison so that we can then actually say what are the differences between them. So if I were to take K's rate at 4 laps and 5 minutes, the way we write it is we turn it into fractional form, but I make sure that I include the units. I'm just going to go ahead and lecture you guys right now after watching last class.
Okay.
Everybody just wants to write the numbers. Nobody wants to write the units. That's actually okay if we were doing ratios, because ratios are a comparison of numbers. But the whole concept of rates is we're comparing units. How can I compare something I don't write down? You can't. So you must write down the units. So if I write the rates for the other 3 team members, what did it say Susan's rate was? Rashad? Thank you. So she did 7 laps in 10 minutes. Notice how we write both the number and the words. You must have both included for it to be a rate. If I just wrote 7 to 10, that's a ratio. When I put it together, now it's a rate. What was Doug's rate? You've already answered a couple. 1 lap in 2 minutes. And then Mako's rate was? So you answered, Samaya. 3 laps in 4 minutes. Here's another key concept. You need to line up the units when you're writing out your ratios. Keeping your units in the same portion of your fraction is critical. Whatever's in the numerator on one needs to be in the numerator of the other. Whatever's in the denominator of one needs to be in the denominator of the other. Don't switch up your units. It's part of the reason we write them down, to make sure that we're getting all the numbers into the correct spots. Okay, we need our highlighters again. We've got another definition here. This is a proportion. A proportion is an equation that states that 2 ratios are equal. So one of the keys in a proportion, you're going to see that equal sign. That equal sign is going to come between 2 fractions. That's what makes it a proportion. When we are dealing with rates, most of the time we're actually going to work in proportions because we're going to be solving something. The fact that it's a equation tells you that the 2 sides are equal. So a proportion, by definition, both sides of it are going to be equal. I have another definition in here as well, and that's what we're actually going to be doing with our proportions. There's 2 we're going to do. We're going to start with scaling up. We'll also do scaling down. When I change a ratio, I do what's called scaling up. That means I'm going to multiply both parts of the ratio by the same factor greater than 1. If the factor was less than 1, we'd technically be scaling down because it's going to be getting smaller. But in a scaling up situation, I'm going to be multiplying both my numerator and denominator by the same number to find an equivalent ratio to keep my units proportional. So lots of definitions on this page, lots of math talk. Any questions on anything we just talked about? Yeah, they're not so smart. Questions on any of this? Okay, let's go ahead and go to our next page then. One way to represent a ratio is in fractional form. It doesn't matter which quantity is in the numerator or denominator. It actually does matter because it's however it was written in English. Whatever's first should be first in my proportion as well. You can write the proportion in a different way. It is acceptable to put your labels into one fraction and then just use the numbers for the proportional piece. That is an acceptable way to write your rates. But your units must be written at some point so that you can keep track of them. Okay? I'll be honest, I don't really like this way as much. I prefer writing it in each piece of my fraction just to make sure I'm putting the numbers in the right spot. So now we're going to determine the number of laps that each student can complete in 20 minutes. Explain the scaling up you use to determine the equivalent ratio. So we're going to start with 1 to give you an example, and then I'm going to let you guys do the other 2. So let's go back to Susan. What was Susan's rate? 7 laps in 10 minutes. When we're going to set these up, let me just give you guys a really easy way to do it. Start, put the equal sign, put your other one, and write your units down immediately. If you do this, it should make it very easy for you. Because anytime they're doing a proportion, they have to give you 3 of the 4 pieces of information. If they don't, you can't solve it. Your key is putting it in the right place. If I have my labels already in place, it should make this very easy because now I look and it says 20 minutes, right? So, where am I going to put the 20? Is it in the numerator or the denominator? The denominator. If you've written your labels, it's a no-brainer, guys. Because it literally says right here, minutes. So if I'm doing 20 minutes, it has to go here. Can you see where writing that out is going to make it easier for you? It literally will basically solve it for you. Now all I've got to do is figure out, how did I go from 10 to 20? Multiplied by 2. So guess what I'm doing on top? Multiplying by 2, and I get... Guys, can I make it any easier for you? You have to be willing to put in the work to write the actual units down. But if you'll do that, this is easy. So you've got 2 more to do. Then I want you to use your information to figure out part 4. Mr. Vandermaiden.
Ladies and gentlemen, this is how next year is. This stuff right here. So learn it now so that Math 7 will be easy for you next year. Okay?
What's the
Okay, I just had a really good question. The question was, well, should I simplify? And the answer when we're doing these types of proportions is it depends on what's being asked. Because if I'm scaling up, but then I simplify, I'm actually just going back to where I'm going. I didn't actually answer the question. So normally, yes, your final answer should always be in simplest form. This is one of those exceptions. If they're asking you to scale up, my answer is going to be the scaled up version, so it won't be in simplest form. So let's look at Doug. Doug's base rate was what? No, Doug's. 1 lap, 2 minutes. Guys, again.
Stop talking.
If you will write down your base frame every time and just throw in your units, the rest becomes easy, because now I know I'm going to 20. 2 to 20 is going to be times 10. 1 times 10 gives me 10 laps. What's my base for Mako? 3 laps, 4 minutes. And I just throw it in, laps, minutes. I know I'm going to 20. 4 to 20 is going to be times 5. 3 times 5 gives me 15. So I now know I have 16, 14, 15, and 10. Who won? K. K got 16. K was the fastest. Doing 16 laps to win the award. Does everybody understand the processes? Okay? I'll be honest, guys, your biggest key today, right there. You're going to have 2 fractions with an equal sign in between them. Make sure you include your units. If you will use this basis of your framework for setting up all today's problems, these should be no-brainers. As long as you've written down the units, everything is going to line up. And even in the word problems, you'll be able to pick out the information you need as long as you're marking your text, and then you should be able to put it in the correct spot. Any questions on this page? That was the last problem, yes. Okay. Okay, let's go ahead and go to page 203. And we'll let Miss McShann take over.
All right, guys, so that was scaling up, yes? What does it remind you of? What are we making? We're making equivalent fractions, and we've gone over this, yes?
Yes.
So scaling up means we are getting bigger numbers in our next fraction. It will not always be the first fraction that we start with. We always start with the one that has a numerator and a denominator. And sometimes it is the second fraction, and you just have to work backwards. But right now they gave it to you first on every one of them. I'm just giving you a warning. So I'm starting where I have a numerator and a denominator. What do I do to 3 to get to 27 feet? What 9? Times 9. So 1 times 9 is 9 yards. It's that easy, guys. Does everybody understand what we're doing each time? Good. I want you to do B, C, and D. I'm giving you 2 minutes, and then we will come back and discuss. Go for it. Okay, remember, you are starting with the fraction that has a numerator and a denominator. So I'm starting at 2. What do I do to 2 to get to 30? By 9? By 15. What do I do to 4 now? Also times 15. And what is 4 times 15? 60 cups. All right? My numerator and my denominator. This time I have my denominator complete on both sides. So what do I do to 3 to get to 9? Times 3. So what is 36 times 3? 108 inches. And D. We're going from 20 quarts to 80 quarts. What do I do? Times 4. So 5 times 4? 20 gallons. Does everybody understand scaling up, making it bigger? Good. Then I want you to do the 2 real-world problems, A and B. Make sure you mark your text. And make sure you label your numbers. Got it? I'm going to give you about 4 minutes to do A and B on number 2. Go for it. Okay, so it says, Jenna buys 2 pizzas for every 6 people she invites. How many pizzas will she need to buy if she invited 18 people? So what is our original rate? What are we starting with? Allison? 2 pizzas, 6 people. Yes? Okay, and then we are going to make a new rate with what information? What did they give us? How many? 18 people. So I need to put it in the same place people is in my first fraction, so it's the denominator. So I'm going from 6 people to 18 people. What am I going to do? So 2 pizzas times 3? 6 pizzas. This is a word problem, so it needs a word answer. She will need to order 6 pizzas. All right, and B, do you have a question? Okay. Stefan runs 5 laps in 6 minutes. How many laps can he run in 30 minutes at the same rate? So what rate are we starting at? Riker? 5 laps, 6 minutes. And what information did they give us for our second fraction? 30 minutes. And again, it goes in the same place that minutes is in the first fraction. In this case, it's the denominator. What do I do to 6 to get to 30? Times 5. So 5 times 5? 25 laps. He can run 25 laps. All right, so I have a question. If scaling up means the second fraction or the second rate gets bigger, what do you think scaling down means? You're going to have to divide. It's going to get smaller. Good job. So you need your highlighter and your vocabulary sheet. Five. 4. All right, so when you change a ratio to an equivalent ratio with smaller numbers, you are scaling down. It means you divide both parts of the ratio to get your second ratio. Does that make sense? It also means you can multiply by a decimal. But right now we're just going to focus on dividing. So let's look at number 1A. It says 6 hoagies for 18 people. And then they say we want to do 2 hoagies instead of 6. So what am I going to do? I'm going to divide by 3. So 18, what am I going to do to that? Also by 3, because remember, to make it equivalent, I need to do the same thing to my top number and my bottom number, yes? So what is 18 divided by 3? 6 people. All right, I want you to use the same method to do B, C, and D, and I'm giving you 2 minutes. Go for it. All right, let's look at B. 100 track shirts for 25 people, but instead I'm only buying them for 5 people, so what am I going to do? I'm going to divide by 5. So what do I do to the shirts? Also by 5, and I get 20 track shirts. Okay, I'm going from 3 tickets to 1 ticket. What do I do? Divide by 3. So $26.25 divided by 3? $8.75. That should be on your paper, guys. Don't skip the ones that look hard. Try them. You should know how to divide money. And we're going from 12 hours to 4 hours. What do I do? Divide by 3. So 720 divided by 3? 240. 240 miles. Any questions about those? Good. I want you to use it in real world problems on A and B for number 2. Make sure you mark your text and label your numbers. They are word problems, so they need word answers. You have 4 minutes. Go for it. 3. All right. Number 4A says Mark bought 12 pounds of bananas for $15. How much does 4 pounds of bananas cost? So what rate are we starting with? 12 pounds for $15. That is our rate. Yes? And what other information did they give us? They want to know how much 4 pounds would be. Pounds is on my numerator, so it's on the numerator of my second fraction. Make sense? So what do I do to 12 to get to 4?
Divided by 3.
I am dividing by 3, so I need to do the same thing to my dollars. And what do I get? $5. So 4 pounds of bananas costs $5. Any questions about that? And B, Jill can type 750 words in 6 minutes. If she types at the same rate, how long does it take Jill to type 250 words? So what rate am I starting with? Riker?
750 words at 6 minutes.
750 words in 6 minutes. And what other information did they give us? 250 words, so I make sure it is equal with the words in the other fraction. What do I do to 750 to get to 250? Divide by 3. So what is 6 divided by 3? 2 minutes. So it will take her 2 minutes. Any questions about those? Good. Let's turn the page. More vocabulary, so make sure you have your stuff out.
So we're back on our vocabulary. The first one we're going to do on this set is a double number line. How many of you are familiar with a double number line? How many of you are familiar with a number line? Okay, the good news is, double number line, you just tried another one above it. But there are some other pieces to it. A double number line is another model that is made up of two number lines used together to represent the ratio between two quantities. Here is a big key on this. The interval on each number line maintain the same ratio. That means they don't go up by the same amount because it's based on how that number line is set up. So the intervals will all be equal between your two number lines as far as it's going to be written right above each other like this. So anytime there's a line on the top number line, there will be a line directly below it for the second number line. But the intervals themselves will be different based on what the number lines start with. Okay, just to help everybody understand, make sure we're good. An interval is the amount of space between two tick marks on a number line. The scale for each number line is different most of the time. If you have a 1-to-1 ratio, it would be the same, would be the only time. But the interval is the same for both lines. In other words, my tick marks are going to be the same distance apart, but the number associated with that tick mark will be different for each of my two number lines. So let's talk about a few of the main pieces of the double number line. Number one, you must label what each of the number lines is. Okay? You must have a label for each of your two number lines. Each of your intervals are going to be exactly the same. So wherever I have a tick mark on one number line, I should have a corresponding tick mark on the other number line. Our double number lines are always going to start at 0. So the first interval should always be 0, 0. If you do these things, your double number line will make sense. If you skip any of them, then it's not going to work out very well. So in this case, we have a ratio of 12 ounces of blue paint to 9 ounces of yellow paint, shown on this double number line. One other key is my first interval should always be whatever the ratio is in simplest form. So if I start at 12 and 9, can I divide 12 and 9 by 2? By 3? Yes. So I'm going to divide by 3. And that's going to give me 4 and 3. So this is going to be my simplified ratio to start for my second interval, because my first interval is 0, 0. Does that make sense? Okay? Once I have my simplest interval, simplest form shown, then we can start doing all of the rest of the intervals in between them. So if we were to describe the interval represented on each number line, what is the interval for the blue paint? How far apart are they? How far apart are my intervals on the top line, guys? This is not a trick question. Mason?
5. There are 5 spaces.
There are 5 spaces, but what is each interval? How much is between each space on the top line? Good? Isabella?
3?
4. Okay, so the top interval goes by 4. That's for the blue paint in ounces. What about the bottom interval? Kiana? 3. The bottom interval goes by 3. Is that okay? Is it okay that this is 4 and that's 3? Yes, that's the whole idea of a rate, guys. My rate is normally not going to be 1-to-1, so they're going to be different. What's not going to change is every time I come to an interval, my numbers are going to be different on the top and the bottom, but they are going to be proportionate. So they will all be equivalent because they're changing at the same rate. So how can Duncan create the exact shade of green she needs if she uses fewer ounces of blue paint? How does it affect the amount of yellow paint? So can't you use less than 12 ounces of blue paint? Would that be okay? Yes. If I do, what's going to happen to the yellow? Will I use the same amount? If I'm using, if I need less than 12 for blue, will I still use 9 yellow?
No.
No, what will I use? Less than 9.
So like,
It's really not a hard conflict. Glad that Riker was able to pull that one out.
shut down.
Good job. So yes, she can use less, but then she will use less. She will also use less yellow. How can Dulcina create the exact shade of green if she needs to use more ounces of blue paint? How does that affect the amount of yellow? Can I use more than 12 ounces of blue? Yes. If I do, what happens to the yellow? I have to use more yellow. Yes, but she will need to use more yellow. Does this make sense to everybody? I can change it. Changing it's okay. But however I change one, I have to change the other one the same way. If you think about what we were just doing, that kind of makes sense, right? If I multiplied one number, I had to multiply the other number. If I divided one number, I had to divide the other number. So whatever I'm doing to one side, I must do to the other. The only difference we're talking about now is the format. Now we're doing the double number line so that you can see them laid out side by side. So we have two different explanations. I want you guys to look at what they're saying, see if you can figure out what Sal is doing wrong, figure out why it's okay for Oliver to do what he did. We'll give you guys about 3 minutes. Good? Who is able to figure it out? Is Oliver's thinking okay? Yes. Why? What's good about his reasoning?
So you see, if you get 1 and you multiply by 4, you have to do the same distance for the other one. So
There's the key. He did the same thing. He multiplied them both by 4. And because it's a proportion, it has to be multiplication or division, which should give you a very big hint. What did Sal do wrong?
he added. May I go to the bathroom?
Make sure you sign out. Mason?
He forgot to use the interval. 4 on top and 3 on the bottom.
Okay. He used a different interval, right? This interval is 3. This interval is 4. He changed the interval. That's why we can't add the same amount, guys. You can't add the same amount. The only time that would work is if I had a 1-to-1 ratio. Okay? But because my interval on top is at 4, when he added 3, he changed the interval. You can't just change the interval on a number line. Let's go and look at our next page. Unfortunately, we're quickly running out of time, believe it or not. 20.
No, 20. We get out of 20. That's right. Oh, we have 10 out of 20. No, fine. No.
Yeah, so we have like 8 minutes. Okay. So guys, I'm going to walk through you with this one with you guys, if you'll quiet down. Okay, so we're going to walk through this first one together to make sure everybody understands what to do. because my first class really struggled on this. So we have 1 pound of bananas, and it costs 50 cents. Determine the cost for each quantity of bananas. So they gave us our first interval. They said, okay, we're going to go every 4 on the top and every 4 on the bottom. But we're going to use our base of 1 pound and 50 cents. What that means is every 4 on the top is going up by 1. Every 4 on the bottom is going up by 50 cents. So then I go up by 4, go up by 50 cents, go up by, go 4 more up, go to 1 and 2. Once you have your double number line set up, this is where it's really kind of nice to have a double number line because it's easy to visualize in between intervals. Our first one should be super easy because at 2 pounds, I literally just go down at that same interval. What is my cost? $1. Here's where a double number line works out well because a half pound is halfway between 0 and 1, yes? So now I know I'm going down. I need the interval directly between 0 and 50 cents, which would be 25 cents. Can everyone see how that works?
Yes.
Okay? Same thing here. If I go halfway between at 2.5 pounds, I'm going to go straight down. So here would be 2.5. What would be halfway between $1 and $1.50? $1.25. So this is one of those areas where a double number line can actually do really well for you, is those intervals in between your direct relationship. Because I can very easily visualize exactly what's happening and figure out what to do to the other number. When we are doing it, remember, our key is our first interval is our ratio in simplest form. So this one, they gave us the width is 8 feet, its length is 20 feet. Determine a rectangle that maintains the same ratio of side lengths for each given dimension. So that's our key task. So we're going to start, if I start at 8 feet and 20 feet, can I divide those both by 2? Here's where your 4 key numbers come in, guys.
Yes.
Yes, so I'm going to divide by 2. That gives me 4 to 10. Can I divide those by 2? Yes. So that's going to give me 2 to 5. 2 and 5 are 2 of my key numbers, so I know I'm done. So I actually know my first interval should be 2 and 5. Now, because of the way this is set up, it actually makes sense to me if I go 2 on the second interval. So that's going to be 2 and 5. So now I've set my first interval. Once you set your first one, all the rest of them are set up. You just need to number them. So for every 2, I'm going up 2. On the bottom, I'm going up by 5. Does everybody understand where those numbers came from? It starts with, again, we always want to have our ratio in simplest form to figure out what our first interval is. We now go at a width, and make sure you're doing the right one, at 2 feet. So I go straight down from 2. What do I get for a length? So my length is 5. What if I go for a length of 22.5? That's actually going to be halfway between 20 and 25. So directly above that would be 9. So my width is 9 feet. And our last one gave us a width of 14. So I go straight down from 14 and I get a length of, let's try that again, length of 35 feet. No, that was just my handwriting wasn't coming out well. Okay, unfortunately, we're down to 5 minutes. So if you want extra practice, you can try it on 8. Again, start by simplifying the ratio they gave you of 9 to 21 for your interval. But for now, let's go ahead and turn to page 209. Keep it down. I need to go over the instructions we need to hear. So, compare and contrast tape diagrams and number line models. Use
Not packing. You are taking out your homework sheet and looking at it while he gives you directions. Period.
If anything, you should be writing down what I'm putting on the board because it's going to help you do your homework. I so remember this one from last year because kids did just like you're doing and didn't pay attention while we went over the homework. And they didn't do a model. What did the directions say? So if I don't have a model and I just have answers, have I done my homework? No, you have not. So you have two problems. Draw a model. They gave you an example you could use for a model, but make sure your model fills what the pieces are asking. Number 2, this one, it's a ratio of 4 hip-hop to 3 country to 1 slow song. Use a tape diagram. So can I just use a regular model like we did for the first part? No, what do I have to use? Tape diagram. For those of you that forgot how to do it, go to last time's video. For those of you that realize I forgot to post the video, we will go ahead and post that before you guys leave today. So both these will be up there. Go to the back side, scale up or scale down. So the bottom line is you're going to be doing both. Look at the numbers they gave you. Remember, this time they made it easy. They gave you the double numbers on the first for everyone. But I always start where I have 2 numbers and then figure out how am I going to the other side. Yes, sir?
Your channel is linked in the rule of classes, right?
Yes. And the last one, they started your double number line. So you'll need to finish your double number line, but it's basically 2.5 bags of mortar for every 100 cement blocks. And then they've given you different numbers. So 350 blocks, 50 blocks, which are going to be between the intervals. So just realize that's what you're doing. Same with 12.5 bags of mortar.
You don't need to write down what he's writing down on your homework.
Okay? So the bottom line is the homework is forcing you to use all the different formats we have taught you to at least give you some practice. The good news is because we have the field trip on Tuesday, this won't actually be due till next Thursday. So you basically have an entire week to get this done, guys. Any questions?
Have a seat.
Any questions, Riker? Yes, you still need the vocab sheet. That's your lifeline. You'll be able to use that on the quiz. Okay, good luck, guys. Good luck, guys.